Hey guys, this video is for lesson 7.2. Our I can statement we're meeting is I can find cube roots, so your notes for 7.2 are going to be really helpful for this assignment. You need to use this video with page 298, numbers 7 through 21 odd. So the problems I'm going to cover, if my video allows it, is number 13, 15, 17, 19, and 21. So just keep that in mind when you're numbering your pages, and let's go ahead and get started. Okay, so our first one we're going to cover is 13. So please do not stress out because you see fractions. What we're going to first look at is our parentheses here with our cube root and our cubed. Now, just like with squares, those actually cancel out, which is really exciting because it makes our math a lot easier. If you ever see a cube root and a cube sign, those automatically canceled out. Okay, so we don't even have to worry about these in this problem. We're just going to bring down this negative 1/8, and we're going to add it to our 3 3/4. Okay? Now, the way to add fractions is we need to make sure they're either all improper or they're all proper. Okay? So or mixed fractions. So we want to make this 3 3/4 match this 1/8. So I'm going to do this. So 4 times 3 is 12, 13, 14, 15. And I know I'm going to keep my same denominator, so 4. Okay? I'm going to bring this down. So I'm going to have 1/8 plus 15 over 4. And if you need to type that into your calculator, that's fine. But if you don't have a calculator, we can figure this out pretty simple. We need to make sure we have a common denominator. So I know I can use 8. So I'm going to take this times 2, and this times 2. I'm going to get 30 over 8. I'm just going to rewrite my problem again. And then it's just adding across. So I have a negative 1 plus 30, which I know is going to give me 29 over 8. Now usually, I don't know what rule this is, maybe some mathematician somewhere, we usually don't want to leave our answer improper. So let's make it into a mixed number. How many times would 8 go into 29? So think about it, and it's going to be 3, okay? So that 8 times 3 would give us 24. We would have 5 left over, so 29 minus 24 is 5, and then we keep that same denominator. So our final answer is going to be 3 5/8. So if I went a little too quick, pause the video, rewind, whatever you need to do. Just remember that awesome rule: when we see a cube root and a cube sign, we can cross those out. Alright, our next one we're going to do is 15. 15 is kind of a doozy, I'm going to be honest. I had to do this one a couple times before I got it, so don't feel bad if you have to rewind or pause this one. We're going to go ahead and start, just like with our PEMDAS, our cubed sign there, or our, let's see, what do you call it? Our cube root is going to be our first step here. So we're going to look, we can't do anything with the 1 really, we're just going to know we're going to carry it down. Now 216, we have to think, what number times itself 3 times equals 216? So I'm going to go ahead and just kind of talk about what I know. So I know that 3 times 3 times 3 is going to give me 27. So I know it has to be higher than 3. Now, 5 times 5 times 5 is going to give me 125. I'm closer than I was with 3, so I'm going to keep climbing up. I'm going to try 6. So 6 times 6 times 6. Put that into your calculator. You should get 216. So what that information is telling us is that the cube root of 216 is going to be 6. So I'm going to rewrite it this way. Since we found this, we can now have negative 1 over 6. Okay? And then I'm just going to put the rest of my problem there. Okay? So hopefully that made sense with the 6. You just want to find that number times itself 3 times. That will get you that perfect cube. Okay. Now this is where it gets a little tricky. If I'm going to do, I took 2 1/6 hold on, my word got a little sloppy here. So if I have 2 times 1 6, let me grab my calculator. So if you can type it into your handy dandy calculator, that's great. I'm going to do that with mine just for the sake of time. Okay, so what I should get when I do this, I don't know what I should get, I guess. Oh, I'm looking at the wrong sheet. Hold on. Okay, here we go. Now, what I'm going to do here is I'm just going to do this, so I'm going to do my 2 over 1, so I'm going to take this down here, and I'm going to multiply it by my negative 1/6, okay? Because I need to multiply that still because this was in parentheses. That's why I was getting stuck, okay? So sorry about that, even teachers get stuck too. So I'm going to take my negative 2 times negative 1, which should be positive 2, over 6. I can simplify this down to 1/3, okay? Like I said, this one was a little bit of a doozy, but the reason I started at negative 2 times negative 1/6 is PEMDAS. I have to do my multiplication first, okay? So now I have left 1/4 and 1/3, but I actually got rid of this negative sign here when I multiplied through, so I'm just going to add these. Now in order to add fractions, I need to make sure I have a common denominator. So looking at this one, I know my common denominator is going to be 12. Okay, so now this is going to equal, I'm going to have 3/12 plus 4/12. And that's going to give me 7/12, which would be my final answer. Sorry about the confusion on that one. I was looking at my wrong sheet, so I apologize. So just know that that cube root is going to be 6 for 216, and that's going to help you in future problems as well. So pause, rewind, ask me in person if you need to. That one was a doozy. Okay, 17. Let's scroll up here. Now we have a 4, and that's going to tell us that it's going to be times the square root of 8,000 minus 6. So we need to start with our square root because that's part of PEMDAS. Okay, so we're going to look at it. Think about what we know here. So if I did, let's see, if I know that 10 times 10 times 10 is going to equal 1,000, I know I have to keep going, okay? So if I put in 11, that's going to be, 1,331. I got to keep going up. So it should be in a range of, let's say, let's just try 12. Okay, so I'm going to type that into my calculator. You do the same. 12 times 12 times 12. No, that's still too low. So we're going to keep moving up. So let's try between 15 and 20. Okay? I'm going to just do 18. 18 times 18 times 18 would be 5,000, so I'm getting closer. 20 times 20 times 20. There's my 8,000. Okay? So I know that the cube root of 8,000, I'm going to get 20 times 20 times 20 equals 8,000. So I know the cube root is going to be 20. Now this is kind of gone, so I still need to multiply this by 4 and then subtract it from 6. So I'm just going to work left to right because it worked out that way. So 20 times 4 is going to give me 80. And then I'm going to have that 80 subtract 6 to get 74. So like I said, you kind of just have to guess and check, but do an educated guess. You want to use problems that you already know those cube roots of and kind of move up that way. Alright, let's keep going. Alright, 19. 19 is going to be where we are going to replace some values with variables. So our variable is w, and every time we see a w, we're going to replace it with 288. So let's go ahead and rewrite it so it's correct. So I have 6 times 288 minus 288. So as always, I need to start with my cube root. So I'm going to grab my calculator and I'm going to do 6 times 288. and I'm going to I still gotta find the cube root, but I got 1728. Luckily it wasn't 1738, because you all would be singing a song. But I'm gonna go ahead and find that cube root. So looking back, what do we already know here? We figured out we was way beyond 8,000, or way below 8,000, so we know we don't need that one. Looking back at our problems here, what one could help us here? Maybe none of them. I thought there was one. Let's go ahead and try 11. So what's 11 times 11 times 11? Figure that out. So, oh yeah, we did have this one. So 1,331. Not terribly off, so let's go up one more. So let's try 12 times 12 times 12. And I'm going to get that 1728. Perfect. So now we know that the cube root is going to be 12. And we're just going to continue with our problem. So we're going to take 12 minus 288. And I'm going to get a big number here. That's okay. And it's going to equal a negative 276. So all you're doing is that one is replacing values and then going through the same problem, type of problem that we've been doing. Last but not least is 21, and I know story problems freak people out, so I wanted to read this one. I'm actually not going to work through it with you, I'm just going to give you some helpful hints, okay? The volume of a plastic storage cube is 27,000 cubic centimeters. What is the edge length of the storage cube, okay? So I put a little hint there, so we need to figure out the cube root of 27,000. Now, with that being said, I'm going to give you a range to try, because we don't want to just guess blind, because that's a waste of time. A range of 20 to 30, and that cube root is going to tell you what the edge length of the storage cube is. So go ahead, pause, rewind if you need to, anything you need to do. If you have any other questions, please let me know, and happy solving.